Good morning. Good morning to everyone. Okay. So, before going for today's concept, as usual, we will have a discussion about yesterday's. Okay. Now, can any one of you tell me word? You can send the word about yesterday's one. Any one of you? What we have discussed in the last class? Okay. So we have discussed about average. We have discussed about law of conservation of mass. Okay, fine. So law of conservation of mass. Right? So that's what it tells, that matters cannot be created or nor destroyed. Right? So that's what we have discussed. Then laws of chemical combination. What do you mean by that? Laws of chemical combination. So we have discussed about, yes, that is with related to law of definite proportion. Right? Law of definite proportion, which tells that element or compound will be having definite ratio, simple ratio of the elements in it. A compound or a molecule will have definite simple ratio of the element in its structure. That's what it tells. Law of definite proportion. Right? Yes, Sneha. Then we have discussed about law of multiple proportion. Law of multiple proportion. So what is that definite proportion? Definite proportion is dealing with a molecule or a compound. A one molecule or a one compound. Okay? But when it comes to multiple proportion, so here we are dealing with more than one compound. For example, two element which will be involved in formation of a two different compound, then what will happen? One element which is combining with the definite or constant mass of the another element, it will be having a simple ratio, whole number ratio. That's what law of multiple proportion talks about. Right? So both the case it is related to weight. In both the case it is related to weight. So that's what it is, multiple proportion. Then yes, Rohan, then we have discussed about Gay-Lussac's law of constant volume, gaseous volume, constant gaseous volume. Okay. So it is applicable for a reaction where gaseous reactants are involved. Right? It is applicable for the reaction where gaseous reactants are involved. Right? So that's where a constant volume or definite volume of gaseous molecules will interact to form the product. Right? So that ratio will remain same. It cannot be different. So that's where it is, to some extent it is with related to this one and this one. Here it is related to weight, but here it is related to volume. So therefore we can call it as law of definite volume. Okay? So law of definite volume. All of you have understood? So that's what we have discussed in the last class. Law of definite proportion by weight, law of definite proportion by volume. So that's what we can tell. So these are some of the laws we have discussed in the last class. Very, very important one. All of them. Anyone they can ask, right? Now, along with that, what and all we have discussed? Then we have discussed about average molecular weight or atomic weight. We will go with the atomic weight. Average atomic mass or weight. So what do you mean by that? Why it is called as average? Now naturally it is applicable for those elements which will be having isotopes. Okay? So most of the elements in periodic table they have the isotopes. Therefore it is applicable for almost all the element. Most of the element they are having the isotopes. So that's where by a percent appearance in the nature, even that one we are going to consider when you are calculating the atomic weight or atomic mass. That's where it is called as average atomic mass. Each isotopes, how much it appears in the nature or it is present in the nature. So even including that one we are going to calculate. So that's where it is called as average atomic mass or weight. So that's where we have carbon 12 which is nearly 99%, that is 98.8%. Then we have the carbon 13 which will be somewhere around 1.1%. And if you take carbon 14 which is very less, which will be of 2 into 10 to the power of minus 10, right? So that's where we have the percent appearance. By considering that one we are going to calculate. That's where it is called as average atomic mass. Then what else we have discussed? Then we have discussed about formula mass. Now can any one of you tell me what do you mean by formula mass? To which type of compound it is applicable? You can just mention which type of compound. Formula mass it is applicable for to which type of compound? Any one of you? Molecular mass, formula mass. The way we are going to calculate it is same. No difference. Okay? But for some of the compound we can also use formula mass. Very good. Ramesha. Yes, very good. It is ionic compound. Formula mass is applicable for the ionic compound. Okay, all of you are correct. It is for ionic compound. Fine. So shall we move to today's one? New concept. That is Avogadro's law. Once again, very, very important only. So that is Avogadro's law. Avogadro's law. So that's where we have the Avogadro's law. Okay. Now, this particular thing you will come across in states of matter also. This particular thing you will come across in the next concept also. So that's where we have the Avogadro's law, stoichiometric equation. Once again you will come across this one. Okay. Now it tells that if I have hydrogen gas. If I have hydrogen gas. Okay. Now if I have chlorine gas. If you observe it carefully, if I consider this one as a reaction, then I have hydrogen gas, chlorine gas, which will get converted into hydrochloric acid, which will be also gaseous in state. So whatever HCl it is present in your laboratory, it is not a pure form. It is a diluted one, mixed with water. A pure HCl cannot be liquid at room temperature. It will be gaseous in state at room temperature. Please remember. So that's where hydrogen gas, chlorine gas, they are reacting to form the HCl. Right? Since we are dealing with the reaction, yes Rohan, since we are dealing with the reaction, if I want to balance the equation, now it will become 2HCl. Very good. It will become 2HCl. Now I can tell this one. Anyway, in detail we are going to study same thing in your next concept, that is stoichiometric equation. But to understand the Avogadro's law, here we can tell that I have got 1 mole of hydrogen. I have got 1 mole of hydrogen, because if I have not written anything, it's understood that there is 1. It's understood. No need to write it once again, right? Same logic is applicable here. I have 1 mole of chlorine gas. So together they will give rise to 2 moles of HCl. They will give rise to 2 moles of HCl. That's where we have the reaction. That's where we can tell that this is the reaction. Now what I mean to tell here is 1 mole of hydrogen gas means how many molecules of hydrogen should be there? How many molecules of hydrogen should be there? 1 mole of hydrogen means how many molecules of hydrogen should be there? Whether we can tell how many number of hydrogen will be there? Any one of you can tell me how many molecules of hydrogen will be there? If I am telling I have got 1 mole of hydrogen with me, I want in number. I know that it is 1 mole. So in that case, with respect to the number, what will be that number? Can any one of you? Likita, you have written 2. Okay, Rohan, you are absolutely correct. Okay, so this is related to 1 mole. That means I should have the Avogadro's number of hydrogen gaseous molecules. I should have the Avogadro's number. Others, why people are writing 2? I am not talking about 2 hydrogen atom. No, I am not talking about atom. Please try to understand the question. Question I am asking here is, if I have 1 mole of hydrogen, in that case how many number of hydrogen molecule will be there? I told. I never use the word atom. See, there is a difference. When I am telling hydrogen atom, then I am talking about H. When I am telling hydrogen molecule, when I am telling that one, that means I am talking about H2. It cannot be atom, right? So 1 mole of hydrogen molecule or hydrogen gas, please remember, whenever we are telling hydrogen gas, it is a molecule. Fine? So that's where Avogadro's number of hydrogen molecule will be there. That means, as you people have written, 10 to the power of 23. 10 to the power of 23. So that's where we will be having the number. In that case, how much chlorine will be there? How many chlorine molecule will be there? According to this equation, how many chlorine molecule will be there? How many chlorine molecule will be there? Fast. For hydrogen, I have written how many number of chlorine molecule will be there in that case. How many number of chlorine molecules will be there? So for hydrogen, I have written. For chlorine, any one of you can tell how many number of chlorine molecules will be there? Yes, it will be same. Very good. It will be same. Avogadro's number only it will be there, because even that is 1 mole. Right? So now here, how much it will be there? It will be 2 moles. That means Avogadro's number multiplied by 2. That many number of HCl molecules will be there. Right? Now, if you go back to the earlier one, Gay-Lussac's law. In Gay-Lussac's law, last class, If you go back there, if I had taken this one as 50 ml, which is the unit for the volume. Simply I am taking one volume, 50 ml. This one also we had written it as 50 ml. Right? So 50 ml, 50 ml, and for this one we had written it as 100 ml. Right? If you observe it carefully, compared to hydrogen and chlorine, definitely they will be having difference in their size. Their size will not be same. They will be having difference in their size. Same logic is applicable for HCl. But although they have difference in their size, what is that you can observe with respect to their volume? What is that? That we can observe that when I have taken equal number of any gaseous molecule, if I take equal number of any gaseous molecule, they will occupy the same volume. They will occupy the same volume. All of you are understanding? That's what we can conclude. That's where we have the Avogadro's law. If you observe it carefully, both are 1 mole. Hydrogen and chlorine both are 1 mole. Both are having equal number of molecules. So therefore they will occupy the same volume. There is no change in the or difference in the volume. That's what Avogadro's law talks about. Okay? Only thing here is these two gaseous molecules should be under same pressure and temperature. That's what we have done in Gay-Lussac's law also. They should be present at same temperature and pressure. Fine. Now these things all of you have understood what I am telling. Now I am going to define the Avogadro's law. You can easily understand if you have understood this particular example. All of you have understood? Any doubt? So that's what I can tell that when I have taken equal number of hydrogen and chlorine, they are having equal volume, 50 ml. Volume I have taken simply. Don't think that, okay, 1 mole of hydrogen always will go with 50 ml. No. Gaseous molecules, it depends. Whatever space you are giving, that much volume they will occupy. Right? Okay, fine. So that's where we have the example. Now we can define the Avogadro's law. I can tell that equal volume of gases at same temperature and pressure, this is very important, same temperature and pressure will have equal number of molecules. All of you have understood? That's what Avogadro's law talks about. Equal volume of gases, that means gases. I have used plural, that means I am talking about multiple gaseous molecules. So equal volume of gases, but all of them should be at same temperature and pressure. This word you have to write. If you simply write it as equal volume of gases will have equal number of molecules, then it is not appropriate. You have to specify they should be at same temperature and pressure. Same thing we have done it for Gay-Lussac's law. So if you go back to the last class, same thing we have done. Right? So that's where we have the Avogadro's law. All of you have understood? Any doubt? All of you have understood, right? And you should remember this one. When I am calculating or when we are going for stoichiometric equation, I will use this particular law. Because we have one concept called as molar volume. We have one concept called as molar volume. Here I have not mentioned that one. Therefore, I had written it as 50 ml to make you understand. Fine. So, but anyway, during finding the or with respect to stoichiometric equation, I am going to discuss about molar volume also. Okay. So, any doubt in this? Fine. So, in that case, shall I move to the next one? Okay. So, next one you can expect for 3 marks. 3 to 4 marks. And many times they have asked. Many times they have asked. That's why I will mention it as very, very important. That is nothing but Dalton's atomic theory. Okay, Dalton's atomic theory. So depending on the marks, we should write the points. If you write extra points, no problem, but you should not write less points. Say for example, 3 marks question has been given, but you have written only 2 marks. Then you are not going to get complete 3 marks. You are going to get only 2 marks because you have written 2 points. Okay? All of you have understood? Now, according to Dalton's atomic theory, because he is the one, atoms means atomio. Atoms means atomio. That is nothing but indivisible. Means you cannot divide it further. It is called as indivisible. That means divisible means it can be divided. Indivisible means we cannot divide it further. So that's where that word atom came. Right? So therefore, he has written that all the matters in this nature, okay, all the matters, they are made up of, all the matters are consists of or made up of indivisible atoms. All the matters are made up of indivisible atoms. Why that word indivisible? That is because atoms cannot be further divided. Okay? So therefore they use the word indivisible according to Dalton's theory. Fine? All of you have understood? That should be your first point. Now while writing the point, this should be the first, this should be the second, that is no compulsory, but point should be there, appropriate point should be written. Okay, fine. So that's where we have the first point. Now next point will be with respect to atoms of a element. Atoms of a element. Now you should tell me what you mean by atoms of a element. What do you mean by atoms of a element? That means if I am talking about sodium as an element, then the atom should be sodium. If I am talking about chlorine as an element, then atom should be chlorine. So that's what it talks about. So element, as I told, it's a pure form. It's a pure form. We have discussed this one in the different types of matters, mixtures and pure. In that we have discussed about the elements. So atoms of a element will have with related to properties I am telling, what should be there? Will have atoms of a element will have same or identical properties. Same or identical properties. Fine. So what I mean to tell here is, if I take sodium element, its atom will have always the same property. They cannot have different property. If I take element as chlorine as an element, its atom will always have similar property or identical property or same property. They cannot have the difference in their property. So this is one chlorine atom, this is one chlorine atom. So this chlorine atom is having different property, this chlorine atom is having different property. No, that cannot happen. That's what this particular statement talks about. That's what this particular statement talks about. Now I can extend it further. See, in the same point, or you can make it as different points. Atoms of different elements. Atoms of different elements. So what should happen? Will be differs in their property. Will differs in their properties. Will differs in their properties. All of you have understood? So in the same way you can continue, or you can make a separate point also. Anything is fine. So atoms of an element will have identical properties, and atoms of different elements will have difference in their property. Okay? So anyway, I will make it as one point only to avoid the confusion. Okay? Now, next statement. With respect to the next statement, which we have already studied, that is related to compounds. That is related to compounds. So what is the speciality of the compound? Whether they are made up of same type of element or different element. You can just mention same or different as your answer. Whether compounds will be having same type of elements or different types of elements. Whether they will be having same type of element or different types of elements. First, you should tell me. Okay, fine. So they should be having different types of elements, no doubt. Very good, Rohan. Now in that case, next statement is related to that. Yes, all of you are correct. I can mention that, I can in the sense, Dalton's atomic theory tells that compounds are made of different types of elements. Different types of elements or atoms. Okay? So different types of atoms. Okay? So that's what it tells. Next point. So compounds will be formed with respect to the different types of atoms. Okay? All of you have understood? So that is next one. Now, last one. That is related to first law of chemical combination. That is law of conservation of mass. See, for example, I have a reaction. Okay? So where hydrogen, chlorine, they are reacted together to form the HCl. Two molecules of HCl. Fine. Now, if I want to see the total mass, on the left hand side, what is that total mass? That is 2 gram for hydrogen molecule. Then for chlorine, it will be 35.5. 35.5. It will be how much? So it will be 71. That means 71 grams. 71 plus 2. It will be 73 gram total mass which are involved in the reactant side. What about the product side? Product side also it should be same. Product side also it should be same. Here also 2 hydrogen and 2 chlorines are present. Same as here. So therefore here also it should be 73 gram only. Can you find? Have you understood, all of you? So what I mean to tell you is, if I take this particular reaction, on the left hand side total mass involved here is 73 gram. On the right hand side total mass produced is also once again 73 gram. So what it means? It means that there is no loss or there is no gaining of any element. Okay? So there is no loss. But if you observe it carefully, if I take the reactant where hydrogen was in bonding with hydrogen, if I take chlorine where chlorine is bonding with the another chlorine atom, but if I see the product where I have hydrogen is bonded with the chlorine, so this is what I can tell, right? So that's where in this reaction hydrogen is bonded with hydrogen and chlorine is bonded with chlorine when I am talking about the reactant. But if I see the product, hydrogen is bonded to the chlorine. So there is a shift in the bonding. There is a shift in the bonding. So instead of hydrogen bonding with hydrogen in the reactant, now it has been shifted to bonding with chlorine. So instead of chlorine bonding with chlorine, now it has been shifted to bonding with hydrogen. So that means there is a shift in the bonding. There is a rearrangement in the element. That's what we can conclude, right? Anyone, all of you have understood? All of you have understood this one, right? If you have understood this one, that's where the last point with respect to Dalton's atomic theory. It tells that during the reaction, there is no loss or gain of element. There is no loss or gain of elements, but there will be rearrangement of elements. But there will be rearrangement of elements or atoms. Anything is fine. Elements or atoms, one and all same. So that's what the last point talks about. That's where the last point talks about. Right? So during the reaction, there is no loss or gain of elements or atoms, but there will be rearrangement of atoms or elements. That's what it tells. That's what we can understand here. Any reaction you take, same thing is applicable. All of you have understood? So these are the 4 points with related to Dalton's atomic theory. Fine? Very important one. For 3 marks, they can ask this question. Okay? So if it is asked for 3 marks, minimum 3 points you have to write. No doubt. We have to write the 3 points. Fine? So that's what? Atoms, that is matters are consist of indivisible atoms. That means atoms cannot be further divided. So atoms of element will have identical properties. That means if I take sodium as an element, then its atom should be having same property. And atoms of different elements, definitely, since they differs in their atomic number, they will have the difference in their properties. Then compounds are made up of different types of atoms, right, or elements. And during the reaction, there is no loss or gain of any element or atom, but there will be rearrangement of the atom or element. Fine? So that's where we have the Dalton's atomic theory. So all these are very important for your exam point of view, board exam. Okay? So any doubts? So if you don't have doubts, we will move to the next one. Okay? So shall we move to the next one then? Okay? So now we will go to according to your textbook only. Already we have discussed with moles, molar mass, atomic mass unit, everything we have done. Fine? Now we will move to another important one. I will not mention it as very, very important and all. I will just mention it as important. Okay? So that is percent composition. That is related to percent composition. Fine. Now what is this meant by percent composition? Now this is applicable when I want to see what is that amount of given element present in a given compound. Say for example, I have glucose C6H12O6. I have glucose molecule as an example. What is the formula? You should be knowing the formula. Okay, otherwise you cannot calculate the percent composition. So I have the formula C6H12O6. Now the question here is calculate the, what is I don't want, I will mention it as calculate the percent composition of carbon in glucose. So calculate the percent composition of carbon in glucose. So that will be the question. Okay. So that will be the question. Calculate the percent composition of carbon in glucose. Now first we have to know what is the molecular formula. We should write the molecular formula. That's where we have the C6H12O6. Now, according to this formula, what will be the molecular mass or molecular weight? I have shown how to calculate the molecular weight of a given molecule. If you are knowing molecular formula, we can calculate. That means 6 into 12, that is related to C6, right? Plus 12 into 1, that is related to H12, plus oxygen, that means 6 into 60, right? 6 into 60, that's where we have 6 oxygen, that is related to O6, right? Yes, all of you correct. Already we did this one earlier. So final answer will be 180 gram. Final answer will be 180 gram. That's where we have the 6 number and 12 as its atomic mass for carbon, 12 number, 1 as its atomic mass, 6 number and 16 as its atomic mass. So final answer will be 180 gram. Right? Now, you can tell me that since we have asked question about the carbon, I can mention that for 180 gram of glucose, how much carbon is present? Please remember, whatever we have to find the answer, that should come to the numerator. Already Likita, she has written, whatever comes the answer, that should come to whatever answer we require the answer for carbon. So carbon should come at the numerator. So for 180 gram, how many grams of carbons are present? That means 12 into 6. That means 12 into 6. So that is 72 gram. That is 72 gram of carbon. We have the 72 gram of carbon. Since we are talking about percent composition, now we have to identify how much for 100 gram of glucose. For 100, how much it will be? For 180 gram of glucose, it is 72 gram of carbon. How much for 100 gram of glucose? So 100 gram of glucose will get cancelled. Now we have to find the answer. Whatever answer comes, that will be in terms of percentage of carbon, gram percentage of carbon, because it is multiplied by 100. Okay, so how much it will be? Fine, it will be 40%. Okay, it will be 40%. You can mention like this, or simply you can mention it as 40% of carbon. That is the percent composition of carbon in glucose. All of you have understood? So that's where we have the formula. Okay. So what is that general formula we can mention? Asked element, mass of asked or interested element or atom divided by molecular weight or molecular mass of the given compound multiplied by 100. That will be the formula which you can use to calculate the percent composition of an element in a given compound. All of you have understood? So mass of asked element. Which element they are asking? Here they are asking about carbon. Then divided by molecular mass of given compound. In which compound they are asking? That one should come here. Then multiplied by 100. So this will be the formula which you can use for calculation of percent composition of any of the element in a given compound. All of you have understood? Any doubts? If you have any doubts, let me know. Okay? Okay. Now, can you do the same calculation for percent composition of hydrogen in water? Can you can you calculate the percent composition of hydrogen in water? First, calculate the percent composition of hydrogen. Calculate the percent composition of hydrogen. Yes, Manjuna. So calculate the percent composition of hydrogen in water. Okay, instead of H2 I should have written water. Formula you should write. Calculate the percent composition of hydrogen in water. Okay. 11.1%. Fine. We will cross check. So what is the molecular formula which I have already written? Molecular formula for water is, yes, all of you are writing. So we will see. It should be correct only. Molecular formula for water, that is H2O, right? So in that case, what should be the molecular weight? What should be the molecular weight of, therefore, molecular weight of water is, fine. So 2 into 1, that is related to hydrogen, plus 16, 2 into 1, yes, 16 into 1. Okay, so first I have to write the number. Anything is fine, but I am maintaining the uniformity, that's all. So 2 into 1 is related to atomic mass. So I will mention it as 1 into 16, that is related to oxygen, right? So final weight will be 18 grams. So final weight will be 18 grams, that is the molecular weight of one water molecule or mole, 1 mole of water molecule. Since I have written 18 gram, it is molar mass of the water molecule. Okay? So in that case, percent composition calculation will be, therefore, percent composition of hydrogen is. So what is the molecular mass of water? Because what is that formula? Formula tells that molecular mass or molecular weight of a given compound, right? Given compound. Numerator, atomic, sorry, not atomic, weight of the given or asked element in the given compound. Weight of the asked element multiplied by 100. Now just fill it. Weight of the element will be, for hydrogen, how much it will be? 2 gram. So divided by molecular weight is 18 gram multiplied by 100. So that is nothing but 200 divided by 80. Whether we will get the same answer? All of you? Okay, fine. That is 11.1%. 11.1% of hydrogen. 11.1% of hydrogen. That is the percent composition of hydrogen in water. That is the percent composition of hydrogen in the water. So in that case, to calculate the percent composition, what and all you should know? To calculate the, yes, all of you are right. So in that case, to calculate the percent composition, what and all you should know? You should know what is the molecular formula. You should be knowing what is the molecular formula of that asked compound, right? Next, you should be knowing what is that atomic weight of individual element. You should be knowing atomic mass. Then you should know how to calculate the molecular mass. How to calculate the molecular mass. And finally, you should apply this particular equation. So this background you should be knowing. What is the molecular formula and what are the atomic weights of those elements present in that particular compound. Then you should know, I know the molecular formula, then how to find the molecular weight or molecular mass of that particular compound. Only then we can apply percent composition. Otherwise, it is not possible. All of you have understood? Now, can you tell me what is the percent composition of hydrogen in hydrogen gas? What is the percent composition of hydrogen in hydrogen gas? It will be 100% because I am talking about a molecule where same type of elements are involved. Right? So naturally it should be applicable for the compound. Percent composition should be applicable for those molecules which are made up of different types of elements. Yes, all of you are right. It will be 100% for hydrogen in hydrogen molecule. That means H2. Right? So naturally percent composition will be applicable for compounds where more than one type of atoms or elements are involved. Fine? So in that case, solve exercise questions. As I told yesterday, you should solve the exercise questions related to these concepts and all. In your check sheet it has been given and send it to Richita madam. Okay na? Fine? So shall we move to the next concept? Okay, next concept can be asked for 3 to 4 marks. Next concept can be asked for 3 to 4 marks. Please remember, sir, ಈ ಚಾಪ್ಟರ್ ಇಂದ ನೀವು ಹೇಳಿರೋದೇ 5 marks ಅಥವಾ ಮ್ಯಾಕ್ಸಿಮಮ್ 6 marks. ಬಟ್ ಎಲ್ಲದಕ್ಕೂ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಆಸ್ಕ್ಡ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀರಾ. So what I mean to tell here is, if this is asked, that question will not be asked. That's what I am talking about, repeatedly asked concept. Okay. So whatever next one I will be telling, it is very, very, very important. Okay, 3 times V I have used. So very, very important, very, very, very important, then only important. So based on that you can see how many times these questions based on this concept has been asked. Fine. So that is with related to empirical formula. Okay, finding the empirical formula and then finding the molecular formula of a given compound. If you want to understand this, first you should know the meaning of percent composition. That one we have already discussed, right? So then that's why we have the empirical formula and molecular formula. Now, before going for the calculation, we will clarify, or I will clarify what do you mean by empirical formula, because all of you know. Okay, bird is blank. 1 minute. Okay, now it's blur. Gauri. Now also it is blur. Or whether it is visible. Okay, fine. Done. So in that case, first I will clear the word. What do you mean by empirical formula? All of you know what I mean by. Okay, still it's blur. Okay. Okay, still it is blur now also. Okay. Closed up, that's what. I close the window. Okay. So in that case, okay, fine, fine. So what I will make it here is, I will clear the word empirical formula. Done. We will start with the class. So that is empirical formula. Molecular formula, all of you know. See, for example, once again, don't think that for Avogadro sir, glucose is a favorite molecule. Basically, I am a biochemistry person. So naturally for me, glucose, I will be a bit fond of glucose, organic compound, right? So molecular formula for glucose, it will be C6H12O6. Fine? That's what all of us will know. If that is the case, I will write the empirical formula for the glucose as CH2O. I will write the empirical formula for glucose as CH2O. What do you mean by that? Molecular formula I have written it as C6H12O6. Now, empirical formula I am writing it as CH2O. Right? So, what you have understood from this? That means, when I am talking about molecular formula, I am talking about difference between empirical and molecular formula. So, when I am talking about molecular formula, yes, Kritik, it is 1:1, ratio it is there, yes, 1:2:1, yes. When I am talking about molecular formula, it gives the information about exact number of each element, present in those compounds. That's what molecular formula talks about. Yes, Ramesha, you are right. So when I am talking about molecular formula, it gives the information about exact number. How many carbon is there, how many hydrogens are there, and how many oxygens are there. That's what molecular formula talks about. But when it comes to empirical formula, it just gives me the information about the ratio of the elements present in those compounds. Okay, nothing else. It will just give the ratio. That means, what is the ratio of carbon, hydrogen and oxygen in glucose? That is 1 is to 2 is to 1. That's what I can see here. But it will not tell how many exact number of carbon, how many exact number of hydrogen, because same ratio even I can write when I will be having the formula as C3H6O3. Then also it will become 1 is to 2 is to 1. Even I have the C6, okay. So C12H24, then O12. Then also I will get the 1 is to 2 is to 1 only. Right? So what I mean to tell you is, when I am talking about empirical formula, I am not at all sure that whether it is related to glucose or any other organic compound. I am not sure. Right? So it is a CH2. So that's where C12H24O12 will also give the same ratio. C3H6O3 will also give the same ratio because it is the simplest ratio for this particular compound. Right? Even for C6H12O6 also it is the simplest ratio. That's where empirical formula gives or tells about the ratio of these elements. That's it. It will not tell what is the exact number of these elements present in that compound. That will be by molecular formula. All of you have understood? That is the difference between molecular formula and empirical formula. Fine? All of you have understood? Okay? So now, anyway, I will stop here. But any doubts related to empirical formula? Any doubt related to empirical formula? Okay, fine. In that case, I will stop here. We will continue in the next class. Okay? All of you have understood, right? So that means in Monday's class, before coming for those class, please practice whatever has been done all these days. This complete week we are done with the basic concepts of chemistry, right? So we have discussed so many things. So try to practice because tomorrow we have a holiday. So try to practice that one. And Monday will come, when you come back, we will be solving some of the problems related to empirical formula. That means finding the empirical and molecular formula by the given information. Okay, how much points? Okay, fine. So Manjunath, when it comes to exam, don't worry, they will not ask the difference between molecular formula and empirical formula. No, they will not ask. For you people to understand for the calculation, to find out the molecular formula and empirical formula, I have given this particular difference. So don't worry, okay? So what is empirical formula if they ask? Then it is for 1 mark. You can tell this is what empirical formula, which will give the simplest ratio of the elements present in a given compound. That's all. Okay? Fine. But otherwise difference and all they will not ask. Don't worry. To make you understand, I made it as 2 tables. Whatever I will be teaching next, which is nothing but finding the empirical or molecular formula of a given compound, that is very, very important. It will be asked for 3 to 4 marks. Okay, na? Any doubts? Okay. No doubts? That's what. When there is no doubt. Oh, okay, Sneha is telling, bye sir. Chalo, right. Okay, simply I was telling, I was making a joke, don't worry. Fine, thank you. Take care.